Hi, this is Greg Monty, and this is the CERT Education series on heat transfer and the basics of heat transfer. All of the modules in the CERT Education series are similar. There will be a general basic presentation on the topic and then some enrichment videos to further explore the concepts. Let's get started with heat transfer. The first question we have is, are temperature and heat the same thing? If you think yes, put one finger near your chest. If you think no, put two fingers near your chest. I think most of you got this right. Temperature and heat are not the same thing. Let's think about even the units of those two things. First, heat energy defined is the thermal energy that is transferred from a matter at a higher temperature to matter at a lower temperature. This is an important point of this module. Heat always transfers from higher to lower. Temperature is a measure of the kinetic energy, the average kinetic energy of particles in matter, how quickly they're moving inside the matter. And heat flow occurs when two objects have different temperatures. The heat flows from the warmer object to the cooler object, or from the higher temperature object to the lower temperature object. Let's talk about units first. A unit is a quantity or measurement. And if you hear just the number 6, you don't really know 6 of what. So you need to add a unit of measurement to the 6, let's say feet in this case. Then you have 6 feet and you have meaning to 6. Let's talk about the units of temperature. What are the units of temperature? I think most everybody knew these. Temperature is measured in 3 ways. Degrees Celsius, which is calculated from Fahrenheit minus 32 degrees times 5/9, or degrees Fahrenheit, or lastly, Kelvin. Kelvin is 273 plus degrees Celsius. For room temperature at about 23 degrees Celsius, it's about 300 Kelvin. Note, Kelvin does not have a degree symbol with it. And what are the units of heat energy? When you eat food and you are dieting, you might want to know how many what the food has. I think everyone got this right. It's calories. When you look at nutritional labels, on the nutritional label it says how many calories are contained in that food per serving size. In this case, 230 calories for a 55-gram serving size, or 2/3 of a cup. Let's begin doing experiment number 1. First, I'll show you an apparatus for the setup. Hello, this is Greg Monty, and this is the demonstration for what you're going to be using in the classroom today. So, what you're going to do in your experiment is to first start off with a cup with hot water in it, and your teacher and or their helper will put some hot water into cup A. Cup B was already filled up by me prior to this video with some cold water, and then this aluminum bar is going to be placed through a foam lid on this side as well as a foam lid on this side, and 2 thermometers will be inserted into the foam as well, and this apparatus will then be inserted into these 2 cups. The foam lid will be pushed down a little bit, and this apparatus will be delivered to each of your tables or stations. When it comes to your station, if the person delivering the apparatus hasn't turned on the thermometer, if you look on the left-hand side, there's an on-off switch, and you can press both of those to turn on the thermometers, the digital thermometers. And then the second thing is to make sure that they're reading in Celsius. The button on the right hand side of each thermometer switches between Celsius and Fahrenheit. They should be delivered to you, turned on in Celsius mode, but if they're not, just take care of that yourselves at your station. So this is going to be used for experiment A. It's going to be hot water in A. Experiment number 1 is going to be hot water in A and cold water or tap water in B. Additionally to that, there'll be one other experiment, experiment 2, which will involve, again, the same apparatus, but both cups C and D will have tap water in them. So that's it, and hope you have a great experiment. Now let's talk about collecting data on your lab sheets for this experiment. First, pick a person to read the thermometers when the bell rings and to report the temperature to the group at the table. Everyone's going to record the temperatures on their lab sheets. And then another person in your group can read the thermometers on the next bell ring and report that temperature to the group. And you can rotate around your entire table doing the reading and reporting. But everyone is going to record. Before we begin the experiment, your teacher is going to walk around and let you feel the bar before the experiment, at least a few people, and they'll tell the rest of the class what the bar feels like on both ends of the bar before putting them in the apparatus. So your teacher will have the students touch the bar, not in their apparatus, before the experiment begins. So the bar should have felt the same temperature on both ends of the bar. Now let's think about the experiment. We're going to have a hot cup and a cold cup with an aluminum bar between the two. What do you think is going to happen during the experiment? Write your hypothesis in your lab sheets. Now, during the experiment, now that the apparatus has been set up and delivered to your stations, feel the bar on both the A and B sides and on the outside of the styrofoam cup. How does it feel? Write your observations in your lab sheet. So take reading 1 at the beginning of the experiment. Record the temperature for cup A and for cup B using the thermometers. And we will be waiting about 45 seconds to a minute between each one of the measurements before taking another reading. So we're going to take reading 2 at the next bell. All right, take your reading 2 and record it on your lab sheets. Also now, feel the bar on both sides of the apparatus on A and B and outside your styrofoam cup and write your observations. We're going to take reading 3 at the next bell. Okay, record reading 3, temperatures for A and B. We're going to take reading 4 at the next bell. All right, take reading 4. And also note again how the bar feels on the A and B side and on the outside of the styrofoam cup, and write those in your lab sheets. We're going to take another reading, number 5, at the next bell. Okay, make your record for reading 5. And we're going to take our final reading 6 at the next bell. Now is a good time to take a look at your data to see if there are any trends. Are the temperatures changing on the A side or the B side? Are you noticing any changes in the feeling of the bar temperature with your fingers? All right, write down your last reading, number 6, for the temperatures of cup A and B. So lab sheet observation 3. Did the temperature of the bar change during the experiment? What about the temperature of the water? If so, what changes did you see? Let's talk about what happened in experiment number 1. You should have seen the temperature decrease in the hot water. The temperature increased in the cold water. And heat was transferred from the high temperature to the low temperature. Always high to low, or from the hotter to the colder object. What is heat transfer? Remember, heat transfer is the movement of thermal energy from a warmer object to a cooler object. Conduction is heat transferred from one particle of matter to another without the movement of matter. This happened in the aluminum bar. Even though heat was being transferred, the aluminum material did not move around. So that's conduction. Conductors transfer thermal heat energy very well. Convection is heat transferred by the movement of currents within a fluid. So in our experiment, the aluminum bar in the cold water cup was radiating its heat into the cold water and causing the cold water to change its temperature. And this happened through convection. The heat was transferred from the aluminum bar to the water. And radiation is transfer of energy by electromagnetic waves. It's heat transfer from a hot object to a cold object. And we saw radiation from the aluminum bar into the air. The aluminum bar is warmer or hotter than the air, and therefore
radiated its heat energy through electromagnetic waves into the air. What is an insulator? Insulators are materials that do not transfer thermal energy well. Insulators slow the transfer of the heat. In our case, we had foam lids, we had styrofoam cups. Those are insulators which slow the transfer of the heat energy. So when you touch the outside of your styrofoam cup, you didn't feel the heat inside the hot water cup, for instance. Are you wearing an insulator today? I think everybody knows this. Yes, shoes, jackets, clothes, they're all insulators. They keep us warmer when it's cold outside. And for firefighters, they keep them cooler when it's really hot in a fire they're fighting. Let's label the diagram for experiment number 1. We're going to use our vocabulary words. You need to record where the conduction is taking place, where convection occurs, where the radiation heat is being released. Note the insulators, the conductors, and the hot and cold water in experiment 1. Draw arrows for the direction of the heat flow, particularly for conduction, convection, and radiation. While you draw and label your diagrams in the worksheet, your apparatus for experiment 1 will be picked up, and experiment number 2 apparatus will be delivered to your tables. This is what your diagram should have looked like. 2 thermometers, hot and cold water cups, and then the heat transfer in 3 different cases. Starting from the upper left, heat was transferred by radiation from the aluminum bar into the air, and then the aluminum bar had heat transfer via conduction from the hot cup to the cold cup, and then heat was transferred by convection. At the end of the aluminum bar in the water, the heat was released into the water and moved around inside the water by convection. We had a conductor, which was the aluminum bar, and an insulating foam lid and an insulating foam cup. And note, the heat was transferred because there was a temperature difference observed between the hot water cup and the cold water cup. They were at different temperatures. Now let's begin experiment 2. The metal bar temperature before the experiment will feel the same as it did before experiment number 1. The bar is outside of the apparatus, and therefore it feels the same temperature on both ends. Let's form your hypothesis. In experiment 2, you're going to have 2 cups of tap water. What do you think will happen to the metal bar during the experiment? Write your answer in the space under observation 4. We're going to collect data the same way that we did in experiment number 1. Take your first reading. Record the temperature of the thermometers for cup C and D. And we're going to take our next reading at the bell. Okay, record reading number 2, and also note how the bar feels and how the outside of the styrofoam cup feel, and make those observations in your lab sheet. We will take the next reading, reading number 3, at the next bell. All right, record reading 3. We'll take reading 4 at the next bell. Okay, write down readings 4, and also note how the bars feel at both C and D and outside the styrofoam cup, and write those observations in your lab sheet. We will take reading 5 at the next bell. All right, make recording 5. And lastly, we'll take reading 6 at the next bell. Is anything different in this experiment from what happened in experiment 1? Are there changes in temperature taking place in the hot cup or the cold cup? Are you noticing any differences? All right, make your last recording under reading 6 for the cup temperatures C and D. Let's talk about observation 5 in the lab sheet. Did the temperature of the bar change during experiment 2? What about the temperature of the water? If so, what changes did you see? What happened in experiment 2? You should have seen no significant temperature change in either cup. Also, you should have seen no heat transfer, because if the temperatures of the two bodies are the same, there wouldn't be any heat transfer from one to the other. Let's compare experiments 1 and 2. Why are the results of experiment 1 and 2 different? Write your answer for observation 6 on your lab sheet. The answer is that experiment 1 had a temperature difference and experiment 2 did not. Was there heat transferred in experiment 2? Why? Was there conduction, convection, or radiation? Was there an insulator or a conductor? Write your answers under observation 7. This is what your diagram should have looked like. Again, we labeled the thermometer, the conductor, the insulators, foam lid and foam cup the same. And C water and D water were both essentially room temperature water. There was no heat transfer by radiation from the aluminum bar into the air. There was no heat transfer by conduction, and there was no heat transfer by convection, because all the temperatures of the bodies of water were the same. There was no temperature difference and therefore no heat transfer. Let's do a knowledge check. What must be present to have heat transfer or flow? A temperature difference. Everybody should understand this. This is the main point of this module. You have to have a temperature difference to have heat transfer or flow. And temperature flows from the hotter object to the colder object. What would happen to the temperatures of the water in the 2 cups in experiment 1 if left to sit all day? The temperatures of the cups would eventually become equal. This is referred to as equilibrium. Are heat and temperature the same thing? If you think yes, put 1 finger near your chest, 2 fingers for no. The answer is no. I think everyone got that right. And last, what direction does heat transfer? Always from warm to cool. This is the main point of this module. Thanks for participating in the CERT educational series on heat transfer.